Our galaxy is vast and mysterious, with billions of stars and planets waiting to be explored. And among them is Kepler-22b, an exoplanet located about 600 light-years away from our solar system, toward the constellation Cygnus. In this video, we'll explore the secrets of this distant world and what makes it so unique. Kepler-22b was discovered by NASA's Kepler mission in December 2011, hence the name Kepler. This world was the first Kepler planet found in the habitable zone of its star, a region around the star where temperatures are just right for liquid water to exist. The exoplanet takes about 290 Earth days to complete one orbit around its star. Kepler-22b's star is very similar to our Sun, a G-type star about 3% less massive than the Sun. Kepler-22b is about 2.4 times the size of Earth, which makes it a super-Earth. Super-Earths are a class of exoplanets that have a mass greater than Earth, but less than that of the gas giants like Jupiter and Saturn. They are typically defined as planets with masses between 1 and 10 times that of Earth. These planets are considered the most common type of planet in the galaxy, despite our solar system lacking one, and astronomers are fascinated by them. Super-Earths can have rocky surfaces like Earth, be covered in oceans of liquid water, or have thick atmospheres like those found on gas giants. Kepler-22b is dubbed by scientists as a water world because it may be covered in a super-ocean. However, its mass and surface compositions are not confirmed yet. Scientists have used various models and simulations to estimate the possible surface conditions and climate on Kepler-22b. These estimates take into account various factors, including the planet's size, distance from its star, and the composition of its atmosphere. One estimate suggests that if Kepler-22b had no atmosphere, its equilibrium temperature, assuming an Earth-like albedo, would be about 262 Kelvin, which is slightly warmer than Earth's average temperature of 255 Kelvin if it didn't have an atmosphere. But the presence of an atmosphere can significantly affect a planet's temperature. If the exoplanet had an atmosphere, this would provide a greenhouse effect similar to Earth's. The greenhouse effect is when gases in the atmosphere trap heat from the planet's surface, causing the temperature to rise. If Kepler-22b had a greenhouse effect similar to Earth's, the exoplanet could have an average surface temperature of 295 Kelvin, which is within the range of temperatures that Earth experiences. This suggests that Kepler-22b could potentially have liquid water on its surface, which is considered a crucial factor for the emergence and sustainability of life. However, another scenario suggests that if Kepler-22b's atmosphere had a greenhouse effect similar to Venus, it could have an average surface temperature of 733 Kelvin, which is much hotter than the boiling point of water. In such a scenario, the planet would likely have a hostile environment that's unsuitable for life as we know it. We don't know much about Kepler-22b's terrain, but scientists believe it could be a rocky world with oceans, just like Earth. However, given its large size, astronomers don't rule out the idea that it might even be gaseous. One member of the Kepler team has raised concerns about the potential habitability of Kepler-22b. He suggested that the planet, at more than double Earth's size, could have an environment that is closer to Neptune, rocky core, large ocean. Further studies and observations are required to determine the actual conditions on this distant exoplanet. At 600 light-years away, further analysis of this world may require more powerful telescopes. By studying the atmospheres and compositions of different exoplanets, we can learn more about how planets form and what conditions are necessary for life to exist. A lot of people comment how it's useless to study exoplanets since they're too far away and thus unreachable. But studying exoplanets can also have important practical applications and benefits here on Earth. For example, this can help advance our technology. The search for exoplanets has driven the development of new technologies, such as sensitive detectors and space-based telescopes, which have applications beyond exoplanet research. For example, the techniques used to search for exoplanets can be adapted to detect other types of astronomical objects, such as asteroids and comets. Also, by learning more about the diversity of planetary systems, we can gain insight into the processes that shaped our own solar system and the conditions that led to the emergence of life on Earth. And then, by comparing the atmospheres of different types of exoplanets, we can better understand the factors that control climate and weather patterns and apply this knowledge to Earth's changing climate. Exoplanet research can also have the potential to inspire future scientists and engineers and to foster a broader appreciation for the importance of science and exploration. Don't forget to watch the video on the right and subscribe. Thanks for being part of Cosmoknowledge.